Alright, hello again. Can we use the total electron content in order to forecast earthquakes? If so, what's a plausible mechanism that would explain this phenomenon? Well, in my opinion, alright, at this point in time, in science, at least the science I'm aware of, no, we can't. So, in case you don't know what total electron content is, it's basically how ionized the ionosphere is, right? So, even though it says electron content, I'm sorry, so you may think it's the amount of negative charge, but there is just as much of not proton but like positive ion content, if you know what I mean. So it doesn't mean electric charge per se, it just means the amount of free charges of both signs pretty much, all right? So yeah, so it doesn't mean any electric charging per se. I mean, ionosphere is electrically charged, but not for this particular reason anyways. So can we use it to forecast earthquakes? As far as I know, again, no, we can't. Uh, so basically, like there was a paper, actually, let me show it to you, in 2011, this one, which kind of sparked the debate in the community of like seismologists. Like there, you may remember the Japan earthquake, the Fukushima, emergency situation, etc., etc. Right? So this paper where he claims, oh, there was a big like enhancement of TEC before this earthquake, and people started looking into it, and people started noticing various difficulties, let's put it this way, with this statement that there have been an enhancement in TEC, and in particular total electron content, right? In particular, this paper, it's open access, you can actually read it, like it's right here, all of it. Okay, so it says TEC enhancement before seismic events is an artifact. It's literally in the title what they mean, all right? And the point is, the point that they're making, or yes, they are making, is that there is, and it has been known for a while, that after an earthquake, because of all the acoustic waves that propagate through the atmosphere, I mean, the earthquake is a pretty loud phenomenon, all right? So there is a depletion in TEC. So the ionization becomes lower above the place of the earthquake, some tens of minutes afterwards, right? How exactly it happens is a totally different story, but it has been known for quite a while that this is a phenomenon. It's so-called ionospheric hole, right? And so, what this paper is stating is that the enhancement before the earthquake is an artifact caused by the choice, the, let's say, improper choice of a baseline ionospheric TEC, right? So since after the earthquake the electron content is low, it may appear that before the earthquake it was higher than should be, right? Just because after the earthquake it's naturally low, and it's been well known, right? So this is what they claim in this paper. They do some like synthetic data where they show that depending on your choice of baseline, you can pretty much prove, in air quotes, that before the earthquake there is an enhancement of TEC, the same amount of TEC, or even lower TEC. All right. So basically, this paper is kind of invalidated if you think about it for longer than 2 seconds, basically. Okay. So no, at least I don't know how. The answer to this question is no, or at least I don't know how. Like it's unknown to me. Maybe it's known to some, obscure scholar somewhere out there, but then again, we have to ask them what exactly do they use to forecast earthquakes. So consequently, the answer to this question is meaningless. I mean, the question itself becomes meaningless, right? What's a plausible mechanism that would explain this phenomenon? Well, there is no phenomenon. There is no enhancement, or at least it doesn't seem to be an enhancement of TEC before the earthquakes, right? Of course, if there was, we may, produce some hypotheses. We may say, there's some inductive connection of the Earth's crust to the ionosphere, blah, 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 whatever. There may be like emission of ions from the Earth's crust, like, there's a radioactive elements being emitted, like radon and things like that, and blah, blah, blah. So I could propose probably more than one hypothesis if that was the case, but it's not the case, so Well, there you go.